Hello, boys and girls. My name is David Burtons, and today I'm going to be talking about why we should make the full switch to nuclear energy. Now, the first question usually becomes, what is nuclear energy? Well, nuclear energy is actually the process into which we use a neutron to actually split a molecule of uranium-235, and will actually, in the split, will cause heat and energy to basically erupt from it. And in the setting we put it in, which is usually a water setting, it'll actually cause steam to basically come up and turn a turbine, which for us makes power because we haven't been able to make power by not spinning something yet. But usually the element we use is uranium, although there are other materials we can use, but for this presentation, we're going to stick with uranium-235. Now, what's the big deal? Well, uranium is already listed as a green energy by the Energy Information Administration, or the EIA. And according to them, there are actually 96 active reactors in the United States, and that number already accounts for 52% of all green energy produced. Now, unfortunately, that actually translates down to a little less than 20% of overall energy we produce, most of it being from stuff like coal and fossil fuels. A single reactor over a year will create about a gigawatt of energy. And on average, a gigawatt of energy is actually enough to power over 300,000 homes. And it is a little undercited because most reactors don't even run every hour of every day of every year. They basically only run about half the time. And there is actually a recorded reactor that in 2019 ran so much, it actually produced 4,900 gigawatts of energy. That is a lot of homes. And moreover, to kind of state an overkill, it only takes about a 1,000 megawatt reactor to actually power a city like Seattle or Boston, which, like I said, it's overkill. But, we'll move over. I mean, what's wrong with wind energy? Wind energy is a green energy, of course, and there's a lot of discord about it. Well, a single turbine doesn't actually create that much energy. It's usually only about 1.64 megawatts of power on average. And that's not a lot. In order to actually power a place like Seattle, you'd need over 600 turbines. And a lot of turbines will also use, for their blades, non-recyclable fiberglass, which fiberglass, I mean, it's nasty stuff. And after a while, when the fiberglass degrades, it can't, like I said, it can't be recyclable, so it actually will sit into a fiberglass graveyard and basically just degrade and go into the environment, and it's very dangerous. But however, a nuclear turbine actually uses nickel, which is way less dangerous and is actually recyclable, so it can actually be used to make different turbines or more turbines. Okay, well, what about solar energy? I mean, solar energy is great. We hear a lot about it. Well, I mean, on average, a single solar panel over a year will only produce about 600 kilowatts of power. That's really not a lot. And there's actually estimates going through that for a single 2,000 square foot home, you'd need about 16 to 25 premium solar panels to actually power it efficiently. And that also depends on where you live. You see, I actually have a map here, and in the more red areas are places where solar radiation is actually a lot more common, which solar panels, of course, would work a lot better in those areas. Whereas most of the country would not benefit as well from solar panels. And, that really goes into, if you live in Mesa, Arizona, you might be okay with a solar panel, like 16 solar panels on your roof. But, in order to actually power a city, you would need miles of land, clear cut, all the trees taken out just to produce the right amount of power. And there's also the fact that a lot of solar panels use dangerous substances like lead and mercury in their production. And if the solar panels were to ever break, you would actually leak these dangerous chemicals into the earth. And it would completely devastate environments. And they're very hard to remove from the ground once they're there. Even taking the ground out, I mean, it spreads. And nuclear isn't perfect, but it is a much better source of power. And there are even experimental reactors in the making. Right now, one of the experimental reactors actually uses thorium. Thorium is a resource that is actually 3 times more abundant than uranium on the planet and can be found nearly anywhere. And it can't be used as a weapon. one of the main things that people are scared of uranium reactors for is because, one, uranium is used as a weapon a lot, as a nuke, and the fact that a lot of reactors have actually melted down due to human error. But I would like to remind everybody that that was in the past. And since then, we've come a long way and we've figured out ways to actually mitigate any kind of meltdown, even the chances of it mitigate. And thorium reactors, which is experimental on its own, we actually can lower the temperature needed to cause the thorium to do what it needs to do. And in order for thorium to actually work, you would need a catalyst, much like plutonium. And the amount of plutonium needed, you can't even use as a weapon anyway. So thorium is a lot safer, more abundant, and is arguably better. So the thing about thorium reactors is at the bottom of the reactor would be this little stop. And if the reactor goes into a point where it's looking like it's going to melt down and gets hot enough, the stop can actually melt and send all of the nuclear material into underground vats, which will be held until they're safe to handle, which would be very good for situations in which there is an accident and there might be a meltdown. So a lot of this stuff in these nuclear accidents can be held. Another common issue for a lot of people becomes, okay, what about nuclear waste? Nuclear waste is actually not that much of a problem in a lot of nuclear reactors because nuclear waste can also be used as a source of energy. We can actually further break down nuclear waste until we get the energy from it. Now, of course, it takes a little bit to do this, but we can do it. We have a lot of uses for nuclear waste. You know, it's not going to be like the elephant foot in Chernobyl forever. But nuclear power is something we should look for. Nuclear power is the future. It is good energy. And I hope that in this presentation, the small amount of facts I was able to get in such a small amount of time will be enough to push your own research into nuclear reactors, especially things like thorium, and hopefully push away all the fossil fuels and coal use we do. Because, I mean, whether you believe in climate change or not, this is the kind of stuff that will actually help mitigate coral reef damage, because that's just what it does. But thank you for listening to my presentation, and I'll see y'all on the flip side.